I'm Brian Dickinson, and this training bite is on class randomization in SystemVerilog. This is the 7th in a series of training bites showing you how to use classes in SystemVerilog, and in this bite we're looking at the randomization of class properties. So you can randomize your integral class properties by defining them as either rand or randc. Rand is conventional randomization, where every value has an equal probability. So here for my rand property P1, there's 4 possible values. Every time you randomize P1, each value has an equal probability of 25%. So close repetition of values is therefore quite common. However, cyclic randomization will go through all possible values of the property before it starts to repeat them. So this breaks out the randomization into a series of iterations. Within each iteration, you go through all possible values of the property without repetition until that iteration comes to an end. When you finish one iteration, you automatically start another. This will again go through all possible values of the property, but in a different order. So close repetition across iterations is possible, but within an iteration you can't have repetition until you've gone through all possible values. Now this is computationally quite intensive, so the implementation may limit the size of the property which is allowed to be randc. Typically this is about 8 bits. If you need a cyclic property greater than 8 bits, you may have to build your own custom implementation. Once you've declared your properties as being rand or randc, you can randomize these by calling the randomize function of a class instance. So this is a built-in virtual method for every class, and you can't redefine or redeclare this method. It returns a 1 when the randomization is successful, a 0 otherwise, and randomization may fail because of constraint violations, and we'll have a look at constraints in the next training bite in this series. So here I have my class, rand class, with P1 being a rand property and P2 randc. I create an instance of rand class in the handle myRand, and I call the randomize method of myRand to randomize P1 and P2. Now you should probably get into the habit of checking the result of the randomize call. Here we feed it into an if statement. It doesn't necessarily give you an error message when the randomization fails, but if it does fail, you probably want to know about it. You can't redefine the randomize method, this is built in, but when you call randomize, this automatically calls 2 hook functions or callback methods. So first of all, we will execute pre-randomize if we find it before the randomization takes place. And then after randomization occurs, if that's successful, we'll look for and execute a post-randomize function. So what you can do is you can define these methods inside of your class, and they're automatically executed as part of the randomize call. So both of these are void functions with no arguments called pre_randomize and post_randomize. You must get the name right in order for these to be automatically executed, and this is randomized with a Z, not an S. So in this example here, I've got my post_randomize function declared in rand class. So now when I randomize the instance myRand of rand class, I will give random values for P1 and P2, and then I'll automatically execute post-randomize to update the parity with the new random values of P1 and P2. So these methods should only be called as part of an execution of the randomize method. You should never call these things directly yourself. A quick word about randomization with aggregate classes. So here we have an example of an aggregate class, randwrap. It has a local rand property, PRW, and it also has a property C1, which is an instance of the rand class. And the rand class contains our 2 random properties, P1 and P2. Now when we create an instance of the randwrap class, myWrap, and we randomize it, we will randomize the local property PRW because it has the rand modifier on it, but we will only push down into the C1 instance of rand class and randomize the P1 and P2 properties there if we have the rand modifier on the C1 property. if you don't declare this property as rand, you do not push down into C1 and randomize P1 and P2. So if it's not declared as rand, it's skipped for randomization. Now you can control randomization with something called rand mode. So every random property has a built-in enable switch called rand mode, which is set to 1 by default. If you set this switch to 0, then the property will not be randomized when you call the randomize method. So you write to the mode by using the task rand mode. If you call this of an individual property, then this changes the mode just of that property, but if you call it of a class instance, the task changes the mode for all of the random properties of that instance. Now you can read the value of the rand mode switch by using the function rand mode. So only rand properties have a rand mode. You cannot call the rand mode methods of a non-random property. That's a compilation error. So let's show you an example of this in use. So P1 and P2 are random properties, but S1 and S2 are state properties, non-random properties. I create the instance of rand class in the handle myRand, and now I call the rand mode task of the myRand instance. I set the argument to 0, and this disables randomization for all of the random properties inside of myRand. Here I selectively pick up the P2 property of myRand and set its rand mode switch to 1, and this re-enables the randomization of P2. Now I can check the status of a rand mode switch by using the function form. I know it's a function because I do something with return value. So here I read the value of the P2 rand mode switch. That will return a 1 because it's currently enabled. And now when I randomize the myRand instance, only P2 will be randomized because the rand mode switch of P1 is set to 0. Now, like I said before, if you try to call rand mode off a state variable, S1, not declared with rand or randc, then this is a compilation error. Rand mode doesn't exist for state properties. So this was a quick look at class randomization. In the next and final bite in this series, we'll have a look at class constraints.